Hi guys, Julian from Telcotex and Etechs Communications here. We're registered cablers, specialise in ADSL and broadband troubleshooting and fault finding. When we go out on a fault test, we need to relay our test results back to the service provider, and sometimes that involves writing up a report with the test data that we've downloaded. I thought I'd show you guys what one of our reports looks like from an actual test that we did in December of 2016. When we go out on the test, there's certain things that we can't relay to the service provider over the phone, so we need to write up a detailed report about our findings, and that usually involves capturing the data, downloading it onto the PC and writing up a report with the software that we've developed. So I just thought I'd run you guys through what the report looks like. So if you call us out on a fault and we need to report the fault back to the service provider, chances are you'll most likely get a report similar to the one I'm about to show you. So what we're looking at here is a report from December 2016. This is an actual report from testing that we did. I've just taken the customer details out just for privacy purposes, but the actual data from this test is as a result of the testing that we did. I'll just go through the first page here. Basically, you'd have your customer details up here, notes from the service provider to let us know what symptoms we're investigating. Down here we've got the exchange details. So this is the Ivanhoe Victoria exchange, and normally you'd have the C and X pair details there, but I've taken those out as well. The line length from the customer to the exchange, which is 2,389 meters. The loss, which is the attenuation that you'd expect for that line length, which is 31.97 dB. Here we've got the cable sections, the main pair, the B pair and the O pair. Down here in this cable column, this is the type of cable that runs from the exchange to the customer, and these are all the different sections in that cable. So each one of these represents one section of cable with a join in between. There's quite a few there, not counting, maybe there might be about 20 or so. The length of each section in this column here, and then in the gauge section we've got the gauge of the cable. So this is pretty much 0.4 gauge all the way from the exchange to the customer. So they're basically the details that we're given just to help us diagnose some of the issues. So what I'll do is I'll start at the exchange end from this tab, and so what we can see here, the DC part of this looks fairly normal. It looks like it's all within specifications, Telstra specifications. We've got the line noise, which is slightly higher than what you'd expect for normal exchange testing. Normally you'd expect around minus 95 dB, so this is slightly higher, but it's fairly common to have that level of noise as well. So this is the TDR that we've done from the exchange C port out onto the main pair, and we can see that at 11 meters there's a downward reflection. So normally a downward reflection would represent a short circuit or a change in the gauge of the cable, but this is the first section here, and it's 0.4, which is the same as the jumper wire. So you wouldn't really expect to have a downward reflection at that point. We've just put some notes here that says that TDR reflection locates the cable between sections 1, or cable segment 1, and the exchange jumper termination. So it says here that we've actually found the jumper wire to be unsoldered, which we've actually soldered, and I'll put some photos of that in after I've explained all this. So the fact that it was unsoldered could be a cause of the downward reflection there. So if the jumper wire is unsoldered, then that can cause dropouts, and also cause noise to be put on the line as well. The next section here is the DSL test from the exchange. So we've got at the C port, we've got a rate of 21 megabits, which is fairly normal for an exchange test. You can see that the attenuation is 1, so that this is a fairly normal test. There's no errors there. Normally if you're at the exchange and you see an error rate on the C port, it indicates that the port might be faulty, but in this case it actually looks quite good. So the customer test, this is from the customer building entry point. There's quite a lot going on here with regards to the background noise. So we've got background noise level of minus 73 dB, which is quite high. Anything under 100 dB at the customer end is considered abnormal. And this chart here, you can see that there's quite a lot of noise above minus 100 dB. So that needs to be investigated. Also on TDR, we've got an upward reflection at 98 meters. An upward reflection normally indicates an open circuit or a high open, which is a join which is not quite open, but it's a high resistance join. So because the loop balance here, the cap balance, is nearly 100%, it's 98%, that would indicate that this isn't a clear open, that it's more than likely a high resistance join. And yeah, that needs to be investigated by Telstra. So we've got that at 98 meters, and if you look at the cable records, it indicates that the join sections 27 and 28 is where this fault lies. So we report that back to the service provider, and they'll organise Telstra to come and have a look at that join, and most likely just re-terminate it, and that would probably fix the issue. So not much else to see here. All the DC voltage and ohms is within specification, so there's not much to see there. Okay, so we'll go to the DSL at the MDF. So you can see that the bit rate here is, well, the sync rate is only 1.5 megabits. So for a 2.3 kilometer line, you'd probably expect considerably higher than that. You'd probably be looking at around about 10 megabit. So this is a lot slower than what it should be. Also, the bit graph here is just chopped out. It's only taking up a small amount of what it should be. Also, we've got a lot of errors there. So the CRC errors is quite high. Normally you really shouldn't see any CRC errors, but here we've got 426 CRC errors. Normally when you see that amount of errors, the service will drop out quite often. And the same with the FEC errors as well. Don't normally cause dropouts, but FEC errors are an indication that there is a fault. And from the socket, we've got a capture there, and you're basically looking at the same sort of thing, around about the same speed. A lot of FEC errors and CRC errors as well. And that's pretty much it. So we're basically we've got the page here, there's service report, which pretty much just summarizes everything in the other pages and puts it all into one page, so the service provider can have a look at it all on one page. And we basically add notes to it for the service provider to get an understanding of what our testing was all about. So we've just got the sync results, lower than expected sync speeds at the socket and building entry point for distance, Attenuation is greater for distance. Bit graph shows channels with low bit uptake due to background noise levels and multiple errors on this loop testing at the building entry point. Also, we've found a false positive to a load coil detection. If you want to Google load coils, they're basically a coil, an induction coil that used to be used for long cable runs. But if you have a load coil on the line on an ADSL line, the ADSL won't work. There obviously isn't a load coil on this line because we are getting some sort of sync, but a lot of the time when you have a fault, you get a false positive for load coil detection. It's just an indication that there is a fault there. And then we've got the TDR notes, same as what we had on the other page. The background noise minus 73 dB. And then we have the exchange testing again like we did before, with the TDR reflection at 11 meters. And then the 86 dB, which most likely won't be a problem, but yeah, it's just something to take note of. And then we just got the summary and recommendations. Just that the reflections, TDR needs to be looked at by Telstra, and the service is severely affected by background noise. So from the exchange test, there was a note that said the jumper wire was unsoldered onto the main pair termination. We've got the video here that shows that it's unsoldered. We've actually soldered that to rule that out as a cause of any problems. So if you've got any problems with your broadband ADSL or just need some cabling done, you can give us a call or send us an email